On example 10, we are given two things. We're given that line L is parallel to line M. We do have a transversal, bunch of angles, and in particular, we know that the measure of angle 2 is 64 degrees. And what we're trying to prove is that the measure of angle 7 is also 64 degrees. So what I want to do is I want to relate these two angles together. What set of angles are they? Like, what are they called? Those things are on different sides of the transversal. They're on the outside of the two lines. These are alternate exterior angles. Alt exterior angles. And we have a theorem that says that if the lines are parallel to each other, which they are, then our alternate exterior angles are congruent. So this is going to give us that angle 2 is congruent to angle 7. And then I'll just be able to convert that into some angle measurements and be able to do a substitution between these two things. Okay, so here's my brainstorming. I'm going to be able to use alternate exterior angles theorem to declare that 2 and 7 are congruent to each other, and then do a little substitution. Now, I've got two pieces of given information here. I'm just going to use them one at a time. I'm going to use them when they are appropriate. You're more than welcome to put them both in the same step, like in step number 1 if you wanted to. The only drawback is that you don't often see what the flow of logic is going to be. Like using this one when it's appropriate shows you step by step how the ideas are related to each other. So on our proof here, we'll start with just the first piece of given information, that the lines are parallel. And then we want to make a deduction based on those two lines being parallel. So we're going to apply one of the theorems or the postulate, whatever is appropriate. And what's appropriate here are that the alternate exterior angles are congruent. Now, when I write this, I can either write this as angle 2 is congruent to angle 7, or I can write this as angle 7 is congruent to angle 2. It doesn't really matter which one I pick. However, I'm going to write it as 7 is congruent to 2. And the reason why is because my proof statement here has the measure of angle 7 on the left-hand side. And I can kind of save myself an extra step flipping that equation over using the symmetric property if I think ahead and I put the 7 on the left-hand side where it should be from the beginning. Okay, anyway, so why is angle 7 and angle 2 congruent to each other? Well, it's because of the alternate exterior angle theorem. Or you can simply say that alternate exterior angles are congruent when your lines are parallel. Alternate exterior angle theorem. Abbreviating every single one of those words. All right, anyway, on number 3. I'm not going to use the measure of angle 2 being 64 degrees just yet, and the reason why is because this is a number, but these things are shapes, and I can't just substitute the 64 degrees in here yet. Not until I turn this into an equation, and that's easy to do. We have to do that in so many of these proofs. What's it mean for the two angles to be congruent? It means that their measurements are equal. So measure angle 7 is equal to the measure of angle 2, and the reason for that is the definition of congruent angles. Now I'm going to use the second piece of given information, which is going to allow me to substitute the measure of angle 2 as 64 degrees. So number 4, the measure of angle 2 is equal to 64 degrees as the second piece of given information. And then just like we did in the previous proof, we can actually use the transitive property. You can use substitution here too, but here's the transitive version of it. Measure angle 7 is equal to the measure of angle 2. Measure of angle 2 is equal to 64, and if we cut out the middleman of the measure of angle 2, we can say that measure angle 7 is equal to 64. It's also substitution in the fact that you would take out the measure of angle 2 and replace it with an equal quantity, which is, of course, the 64 degrees. So on number 5 here, I'm going to say the measure of angle 7 is equal to 64 degrees, which is what we wanted to prove. And the final reason here is transitive POE this time because we're working with equations and numbers. And then again, like I said, that I would be perfectly okay if you put substitution there instead. All right, there's one more proof from this lesson. It's example 11, and this one I want you to do with your table mates there. And let's talk through it a little bit first. There's not going to be a full-blown video over this, but I'll probably post for you the answer to it so you can check your work. But what we have here, another two pieces of given information. We're not trying to prove a theorem, so we can use whatever is appropriate here. Angle 1 and angle 3 are supplementary. Of course, that means that these two angles add up to 180 degrees. Okay, and then we're also given that angle 2 and angle 3 are supplementary to each other. Congruent to each other. Yeah, they're congruent. It doesn't look like they're congruent to each other, but it's marked and it's declared. So this picture obviously is not drawn to scale. Now, based on that, we're trying to show that these two segments here, RA and TD, are parallel. So what I'm going to highly recommend that you do is try to brainstorm some ideas. How are you going to link these pieces of given information to get these two lines parallel? And in order to get those lines parallel, you need to find basically one of these sets of angle pair relationships. You need to show that some corresponding angles are congruent, some alternate interior angles are congruent, alternate exterior angles are congruent, or possibly some same side interior angles being supplementary.